Hello everyone. So today we will discuss about another method named as a bisection method. Okay. So in my previous video we discussed about the most simplest and easiest method, that is the Newton-Raphson method, and this method is quite lengthy compared to the Newton-Raphson method, but if we grasp the concept of the bisection method, then it is easy to you. Okay, so here is the bisection method. So in my previous video I already tell you the intermediate value theorem. So the intermediate value theorem says that if the equation is in the form of f of x equal to 0, then its root lies in the interval a comma b if condition applies if f of a into f of b less than 0. Okay, so in bisection method, as the name suggests, bisection, that means bisect. See here, if a is here and b is here, okay, and if a is positive and b is negative, then bisection means what to do. So you should do the bisect. I am telling you the concept here, okay, not I am actually doing the bisect here. Okay, if a is here and b is here, and the sign of the a is positive and the sign of b is negative, assuming, then if I bisect this, then the midpoint, bisect means I simply do the midpoint or find the midpoint of a and b. Okay, so m0 is the midpoint here. So if m0 is positive, okay, see here carefully, a is positive, b is negative, and m0 is also positive. Okay, m0 is the midpoint of a and b. And if m0 is positive, then tell me the root lies in which side, left side or right side? The root lies in the right side. Why? Because as the intermediate value theorem says, that the condition is f of a into f of b less than 0. That means root lies in between the positive and the negative. Got it? I will tell you. So here is the positive and the positive. The root never lies in this section according to intermediate value theorem. So m0 is positive and b is negative. That means the root must be lies in between m0 and b. Got it? And again do same process. Find the midpoint of m0 and b. Simply do m0 plus b by 2. You will get the m1. And if m1 becomes negative, I will tell you how the signs will be positive and negative. I will tell you later. So see here, if m1 is negative, then in which side? This is the side in the second part. Okay, so if we bisect this, we will get the m1, which is the midpoint of m0 and b. Now this is one part, this is another part. Okay, so in which portion the root lies? The root lies in between m0 and m1. That means in this point, in between this point. Why? Because this is plus and minus, and according to intermediate value theorem, f of a into f of b less than 0. And this happens when one is positive and another is negative. Okay, either a positive and b negative, or a negative and b positive. So in this portion the root lies, or again this is the iteration process, you can say it iteration, or you can say iteration process. Okay, so see here I am taking an example. So in numerical analysis you face the questions like cos x minus x to the power x e to the power x equal to 0, and the question is find the root of this equation using the bisection method correct to 3 decimal or 2 decimal places. Okay, so see here how to do it. So this is in the form of f of x. I already tell you in my previous video. Okay, so this is f of x equal to this equation, and simply put 0 1 up to when until you get your desired location, or you can say if f0 here is positive and f1 is also positive, then you should go through f2 or f3 or f4 until you get a positive and a negative, or a negative or a positive adjacently. Okay, so here f0 put 0 in case of x, so cos 0 is 1 and this will be 0, and 1 is greater than 0. And see here f of 1, and f of 1 put 1 in case of x. I already tell you how to do it in my previous video. I am using Casio 991 ES Plus and power on the calculator. And already I told you in numerical analysis you should do all the problems in a radian mode. Okay, so for this press shift mode. Here is the radian in the fourth section, press 4, again shift mode. Here is the math 10 and the line 10. So it is better for you to use the line 10 for easy for you. So press 2. Okay, I am doing the f of 1. Okay, so press cos 1. Okay, here is the cos 1, bracket close, then minus 1, and here is the e to the power x. So for exponential, here is here it is the e, that means exponential. Okay, so it is in yellow color and the shift button is also in yellow color. So for accessing this key, so you should type shift long. So it is in exponential form. Okay, then in case of x I am typing 1. Okay, see here this value, okay, which is less than 0, that means it is negative. So since f of 0 and f of 1 less than 0, so according to intermediate value theorem, the root lies in 0, 1, 0, 1. Okay, so see here how to approach this question. In first approximation, or you can say in the first iteration, here the a0, here I am telling in the first like this a0 and b0. So here in this question a0 equal to 0 and b0 equal to 1. Okay, so now find the midpoint, that is m0, that is a0 plus b0 by 2. Now see here how to do it. Simply all clear. Now a0 b0, put a bracket first here, then this is 0 0 plus 1, close a bracket, divided by 2. This is 0.2. You should do like this. Okay, so all clear. So the midpoint is 0.5. see here a0 which is 0, and when a0 is 0, that means in f of 0 it is positive, and 1 is greater than 0 na, so it is positive. So a0 is positive and b0 is 1. In when it is 1, then f of 1 equal to the negative, that is b0 equal to negative, and the midpoint is 0.5. Okay, so the mean m0 equal to 0.5. Now it is important to know the sign. Okay, now see here how to get the sign of the m0. Okay, so here I am getting the midpoint is 0.5. Now we have to do is simply put 0.5 in this equation, that is cos x minus x e to the power x. So you can put this here. Okay, So for this, press 0.5 and I will store in the variable that is a. Press shift store then a. So it is stored in the a. Okay, so all clear. Now here is the equation, that is cos. In case of x, I should write the a in which the 0.5 is stored. Okay, so for type the a, you should write alpha a, which is in the pink color, then close a bracket, then minus. In case of x, I should write alpha a, then e to the power alpha a, close a bracket, equal to. So see here, it is 0.0532 and so on. Okay, and this number is positive, which is greater than 0. Okay, for this the 0 point, as the f of m0 is positive, the sign of the m0 is positive. Okay, for this the m0 equal to positive. So here it is positive. So what to do is, the according to intermediate value theorem, the root lies in between m0 and b0. Why so? Because the root always lies in f of a into f of b less than 0 if the condition is satisfied. F of a is m0 and f of b is b0, and this is positive and another is negative. Positive and negative is negative, which is less than 0. So the root lies in this section. So here you should write, since f of m0 into f of b0 less than 0, so by intermediate value theorem, the root lies in m0 and b0, m0 comma b0. So now see here what to do is, proceeding similarly, the calculated values are tabulated below. Then what we should do is, then we create a table in which we mention these things in tabular format, which is the easiest way to solve the equation to find the root using the bisection method. Okay, see here. So here it is the tabular format of the question, that is the equation is cos x minus x e to the power x equal to 0. Okay, that is f of x equal to cos x minus x e to the power x. Okay, so see here in the tabular format, here it is k, then a k minus 1, m k minus 1, b k minus 1, and it is f of a k minus 1 into f of m k minus 1. Okay, so it is the serial number, you can say, or the number of steps. Okay, so see here, when k is 1, that means k is 1, then a 1 minus 1 is 0. What is the a0 in this question? In the previous, that is a0 equal to 0 and b0 equal to 1, we already get. Okay, so a0 equal to 0 and b0 is 1, and a0, when I am doing f of 0, that is cos 0 is 1 and it is 0, which is greater than 0. 1 is greater than 0 na, so f of 1 is minus 2 point something, so which is less than 0. Okay, so in f of 0 it is positive and f of 1 is negative. So as the f of 0 is positive, so you should write in the sign of the 0 is positive in pencil. Okay, later you erase it. Got it? Then when f of when you type the 1 in case of x, then f of 1 is minus 2 point something, which is less than 0. So the sign of the 1 is negative. Got it? So f of k minus 1 into f of m k minus 1, that is this one, this into this, and this is positive into positive, which is also positive, that is greater than 0. Now the midpoint is 0.5. see here, zero plus 1 bracket close divided by 2. okay, this is 0.5. now what to do is store it in a variable a. for storing you should type shift store a. okay, so the 0.5 is stored in the a. now press all clear. okay, now the question is cos x minus x e to the power x, which is the f of x. okay, so cos, in case of x I should write the alpha a. okay, cos alpha a. okay, cos a minus x into e to the power x, that means alpha a into e to the power. for exponential you should type shift long, that is the exponential, and e to the power a means alpha a, bracket close, enter. okay, so this is 0.05322, and the midpoint is 0 plus 1 by 2 is 0.5. as the when 0.5 is placed in case of x, then it is this one, okay, which is a positive value. so for this the 0.5 is a positive. okay, now the 0.5 is positive and 1 is negative, and the root lies between m0 and b0. so this positive value is going to here, and here is the negative value. that means the 0 is replaced by the positive value, as it is positive. so the 0.5 is replaced. okay, sorry, as the 0 is positive, so it is replaced by the 0.5. okay, which is also positive. so here it is 0.5 and it is 1. then again do all clear, then find the midpoint of a 0.5 and 1. 0.5 plus 1 bracket close divided by 2, this is 0.75, and the sign is negative. why? see here, store the 0.75 in the variable a. so for storing press shift store a. okay, then press this button upper space 2 times, 1 2. okay, so put the value in this equation. so simply type equal to. see here it is negative. okay, as it is negative, so the sign of the 0.75 is a negative. so as you say that according to intermediate value theorem, the root lies between a positive and a negative value, or you can say negative and a positive value. as here it is negative and here it is negative, this one is replaced by this number. okay, so 0.75 is going to here, and the 0.5 is as it is. now find the midpoint of a 0.5 and a 0.75. okay, so for this press all clear, then enter 0.5 plus 0.75 close bracket divided by 2. this is 0.625. again same thing, you should store it in the variable a. for storing shift store a, then upper space 2 times. okay, why so? because it is going to put in this equation. then press equal to, here equal to, it is negative. okay, it is negative. so 0.625, the sign of the 0 in this number is negative. as it is negative, so the root lies between 0.5 and 0.625. that means here it is positive and it is negative. the root lies between these two numbers. so this number is replaced by this number. Okay, so 0.625 is going to here and 0.5 is as it is. So same thing, find the midpoint of a 0.5 and 0.625. So press all clear. 0.5 plus 0.625 close bracket divided by 2. So it is 0.5625. So same thing, how to find out the sign of this number. Same thing, it is going to be stored in the variable named as a. For storing, shift store a, then upper space 2 times 1 2. It is redirected to the page in which the equation lies. Okay, so hit the equal to button. So here is it negative. Okay, so this 53125 is negative. Okay, so same thing you can do further, same process. Okay, and this one is you can do by seeing these two columns, that is, if it is positive positive, then it is positive positive negative negative positive negative negative, and so on. Okay, and in the last you should write the root corrects to. If in the question it is given that find the root of the question something like up to 2 decimal places, then you should see 0.51 here, and in the it's above step it is 0.51 here. When those two steps are equal, then the root becomes this one. Okay, got it? If it is 3 decimal places, so here is 0.517, but here is 0.519, which is not equal to this one. Okay, so same thing again, do step 10, find the sign of the this one, same process, then similarly do up to you get the 3 places similar if it is given the 3 decimal places. Okay, so in this question it is given that to find the root correct to 2 decimal places. So here it is 0.51 which is equal to its preceding step. Okay, got it? So this is all about the bisection method, how to approach the bisection method questions. Okay, so here all it is about. So thank you.